So hello everyone, today we will understand what is K-means algorithm. So K-means clustering is an unsupervised learning algorithm that is used to solve clustering problem in machine learning and data science. So unsupervised learning algorithm because here the model is trained using the unlabeled data set and without any supervision. So K-means algorithm groups the unlabeled data into different clusters. So before starting with the K-means algorithm, we need to define or we need to predefine the number of clusters used in this algorithm. So for example, here if k is equal to 3, k defines the number of clusters. If k is equal to 3, there will be 3 number of clusters. If k is equal to 5, then there will be 5 clusters. So with the help of this diagram, you can understand how K-means algorithm works. So before K-means is applied, here the data points in the data sets are unorganized, or you can say they are not categorized into a particular group. But after applying the K-means, the data points that are near to each other will be clustered into one group. So how K-means algorithm partition the data? Here each point belongs to a cluster with nearest mean. So the data points that have minimum distance or that are near to each other will be clustered into one group. As you can see here, these data points are near to each other, so they are clustered into one group. So the data points in one cluster have high degree of similarity. So all the data points that are near to each other are similar to each other, so they are clustered into one group. Third, the data points in different clusters have high degree of dissimilarity. So now we will understand how K-means algorithm works, or what are the steps in K-means algorithm. So step 1, so select the number of cluster k. So as I have told, we need to predefine the number of clusters, that is k. Step 2, select random k points or the centroid. Each of these cluster is associated with the centroid value. So this centroid value can be taken from your data set itself, or it can be outside the data set. Step 3, each data point is evaluated and assigned to one of the cluster with minimum distance. So different distance formulas or distance algorithms can be used to calculate the distance between the data point and the centroid. If the distance is minimum, then that data point will be allocated to that cluster. Step 4, each time new data point is added to a cluster, then the centroid is calculated or recalculated. So whenever we add a data point to a cluster, then we need to update the centroid of that cluster. Step 5, repeat the step 3 and 4 until all the data points are grouped into clusters, their respective clusters. So now we will take an example so that you can better understand the steps involved in the K-means clustering. So here we have the data set which consists of the height and weight. So here there are 4 data points. And we are going to use Euclidean distance to calculate the distance between the centroid and the data point. So Euclidean distance is XO minus XC whole square plus YO minus YC whole square, where your XO is observed value for your height, XC is your centroid value of your height, YO is your observed value of your height, and YC is your centroid value of your weight. So step 1 is defining the number of clusters k. So here we will take number of clusters k equal to 2. So now we will go for the next step, that is selecting the random k points for the cluster. So we have taken two clusters, and second step is select the random k points for the centroid. So this is the centroid for the cluster k1, and this is the centroid for the cluster k2. As we know that the centroid value can be from the data sets itself, or it can be outside the data set. So we are going to take centroid value from the data set itself. So centroid value for cluster k1 will be your data point 1, that is 185 and 72, and the centroid value for k2 will be your data point 2, that is 170 and 50. 56. So now we will calculate the Euclidean distance for cluster 1 and your observation value 3, that is the data point 3 will be your observation value, that is 168 and 60 is your observed value, and that is the data point 3. So the Euclidean distance for cluster 1, so according to the formula, it is observed value of your height. Observed value is 168. Then centroid value of your height. Centroid value of cluster K1, that is 185 whole square, plus observed value of your weight, that is 60, minus observed value centroid value of your weight, that is centroid value of your cluster 1, that is 72 whole square. So after solving this, your centroid your Euclidean distance for the observed value 3 and cluster 1 is 20.80. Now similarly we will calculate the Euclidean distance for cluster 2. Here your observation value or observed value will be same, only your centroid value will get changed because it is cluster 2. So observed value of your height is 168 itself. Then observed centroid value of your cluster 2, that is 170 whole square, plus observed value of your weight, that is 60, minus centroid value, that is 56 whole square. After solving this, you get the value as 4.46. As you can see, the observed value, that is our data point 3 with the value 168 and 60 is near to cluster K2 because the distance is very minimum. The distance is 4.48. So the observed value 168 and 60 gets added to your cluster 2 as its distance is minimum. So now your cluster 1 will have the data point 1 and your cluster 2 will have the data points as 2 and 3, that is 168 and 60 because it has minimum distance. Now our step 4 is we every time when we add a data point to our cluster, we need to recalculate our centroid value. So now we will calculate the centroid value, that is new centroid value for your cluster K2. So to solve it, the formula is your observed value plus your centroid value, that is 170 by 2, and this is for your height, and for weight observed value is 60 plus centroid value is 56 by 2. So after calculating this, you get the value as 169 and 58. So now your centroid value for your cluster 2 gets changed, but the centroid value for your cluster 1 will remain as it is. So this is cluster K1. So here the centroid value is 185 and 72 itself. It has not changed, and your centroid value for K2 is 169 and 58. So now we will calculate the distance for observation 4, that is data point 4. So again same steps we will follow. For cluster K1, the Euclidean distance, here your observed value will be 179 minus your centroid value, that is 185 whole square, plus your observed value for weight, that is 68, minus centroid value, that is 72 whole square. So after solving this, you get the distance as 7.211. So now again we will calculate the Euclidean distance for K2 cluster. Observed value will be 179 minus the centroid value. The updated centroid value is 169 and 58. 8 for cluster 2. So 169 whole square plus your observed value, that is 68, minus centroid value, that is 58 whole square. So after calculating this, you get the Euclidean distance as 14.4. So on the comparison of K1 and K2 cluster, the distance between the data point 4 and the cluster K1 is minimum. So now we will add the data point 4 to our cluster K1 as the distance is minimum, that is 7.211. So now the K1 cluster consists of your data point 1 and data point 4, and your cluster K2 will consist of your data point 2 and data point 3. So now we will calculate the new centroid value for cluster K1, because the distance between the data point 4 and the cluster 1 is minimum. So now we will recalculate the centroid value. So new centroid value for cluster K1 is equal to your observed value, that is 179, plus centroid value 185 by 2. Then your observed value for weight, that is 68, plus centroid value 72 by 2. So on this calculation you get 182 and 70. So now the centroid value for cluster K1 gets changed, and it will become now 182 and 70, and the centroid value for cluster 2 remains the same, that is 169 and 58. So now all the data points from your data sets are assigned to one of the clusters with their minimum distance. So this algorithm ends over here. So this is how we calculate the k-means clustering for each data point in the data set. So thank you.